Okay, let's start with number one. What distance has this guy traveled? Let's see. A truck driver drives, let's go ahead and draw north, east, south, and west. He travels 8 kilometers east, so he's going to go, this is for letter, oh, sorry, let's start with letter A first. Okay, so he travels 8 east. And then he travels 3 kilometers west. Okay, then he goes back this way. It's 3 kilometers west. Oh, that's kilometers there too. And then lastly, he travels 12 kilometers back east again. So starting at the head of this one, he goes 12 kilometers back east. Okay, total distance is for letter A. For letter A, he goes 8, and then he goes 3, so 8 plus 3, 8 plus 3 plus 12. So total distance, he adds up all these, and these are kilometers, kilometers, kilometers. So 8 plus 3 plus 12, Miss Moore uses a calculator. Don't be ashamed to use a calculator. Oh, actually, not plus, oh yeah, plus 3 plus 12. And I get 23. So 23 kilometers. So he goes this way, 8, 9, 10, 11, and then all the way over there, 23. Okay. Now, letter B is a little bit different. Letter B is the total displacement. So don't forget the displacement is the shortest straight line path from one to the next. So this is a vector quantity. So what does that actually mean? Well, let's look at our lines here. So right here, we have them going 8 kilometers east. Let's call east the positive direction and west the negative direction, because this is like the positive way, the number line, and the negative way. So we'll go 8 this way. So I'm going to say, plus 8. And then I'm going to add, 3 this way, a negative 3, plus, then we go 12 that way, a positive 12, okay? So basically it's 8 plus a negative 3 plus 12. Okay, we get 17. And that is our answer for our displacement. Okay. While following directions on a treasure map, a pirate walks 45 meters north. Okay, north is that way. And then turns and walks 7.5 meters east. So he walks really far this way. 45 meters north, and then 7.5 meters east. What single straight line displacement could the pirate have taken to reach the treasure? Okay, so what they're really saying is the single straight line path, the displacement from point A to point B is right here. It's just our resultant. So we're just trying to figure out what this is. There's 2 parts to this. Figure what the magnitude is, as well as find the direction. So let's start off by finding the magnitude. So I can just do a squared plus b squared gives me c squared. So I'm going to say 45 meters squared plus 7.5 meters squared. And let me get my answer key so I don't have to do all that. Back. Huh?
Is there a back
Is there a back?
to the paper?
Oh no, just front. So my sister is recording today. Sorry. And because my phone storage, Miss Moore had she had a breakdown because my phone storage wouldn't work. So she came and she's recording on her iPad, and she is not used to holding the camera for this long. Mr. Boykin is, but not her. Okay, so I plug these in, and the answer that I get is, I get 45.62 meters. And if you put 45.6 or 46, that's fine. Okay, so that's great. That's all good. However, we need to know about the direction. So let's see. This is 45 meters north, and then this is, then the person walks east. So this one is going to be right in here somewhere. All right, so that means that we don't have to do anything fancy once we get our angle. So let's go ahead and find this angle right here. I'm starting right here. It's my angle. It's kind of like this. North, east, south, west. And you can see where it's at. Okay, So if I want to find the angle, I'm going to do the inverse tangent of 7.5 divided by 45. Can you see this stuff?
Mm-hmm.
Inverse tangent of 7.5 divided by 45. It's almost like we have a special guest with us today. Okay. 9.46. I'm going to call that, I called it 10 degrees over here. Whatever, I'll just call it 9.46 degrees. Okay, so right here, that's 9.46 degrees. And since this is north and we're going east and this is 0, I can just be 9.46 degrees. So it's 45 at 9.46 degrees. This is your final answer, ladies and gentlemen. Number 3, and don't worry, no back. Okay. All right, so Emily passes a soccer ball 6 meters directly across the field to Kara. Okay. Now I'm just gonna say that 6 meters is this way. It doesn't matter if you chose a different way; your numbers will still make sense. And then she kicks the ball 14.5 meters directly down the field, so down this way, not up, down. 14.5 down the field. What's the ball's total displacement? So basically from point A to point B, straight line path. What's the deal with this? Okay, now again, before we even start, okay, this is the origin right here. Okay, think about it like this: north, east, south, west. And so this time, our final displacement vector is going to be somewhere down here. So we have to think about that whole angle right there. Okay. So let's start off with doing Dyke's theorem. We got to figure out what the magnitude of this is, what the displacement is. So C equals the square root of a squared, we'll call 6a. If you use this as a, it doesn't matter. Meters plus 14.5 meters. C equals, I got 15.7. Okay, now let's figure out at what degree. Okay, what's our number here? So here's our angle right here that we can figure out. We know the inverse tangent of the opposite over the adjacent. I'm like flipping you guys off here. I plug that into my calculator. And I get, I'm going to call it 68 degrees. What did I call it over here? Perfect, okay. So this angle is 68 right here, but what about from here to here? That is 90, yes? Right, Steph?
Yes, sir.
Okay.
Ma'am.
So 90 plus 68 is going to get me the whole chalupa there. So 90 plus 68, 158. Is that what you said?
I said because you need the red angle like on top.
Yeah, I need this part too, and this one. Okay. Okay, so there it is. Your final answer is 158 degrees, 14.7. Oh, Miss Moore forgot her units, meters. Okay. So another thing you could do for this one, you could have said 68 degrees below the horizontal. Because this is the horizontal, it's 68 degrees below it. Yeah. Okay. Let's do letter number 4. A hummingbird flies 7.2 meters along a straight path at a height of 3.4 meters above the ground.
1.2 meters?
Mm-hmm.
Is it 7.2?
Oh, 1.2. 1.2. 1.2. Okay. So a hummingbird flies 1.2 meters along a straight path 3.4 meters above the ground. Let me see what I got over here. Along a straight path that has 3.4. Spawning flower below, just directly below. What is a hummingbird total displacement? What is the 3.4 meters for? I don't know. Okay, so a hummingbird flies 1.2 meters along a straight path. Boom. Oh, let's make it to 3. Let's make it pink. Okay, at a height of 3.4 meters above the ground. Upon spotting a flower below, he's like, see see the flower. The hummingbird drops directly downward, 1.4 meters directly downward. So he literally like plunges, like, oh, wrong color. He literally plunges whoosh, downward 1.4 meters to hover in front of the flower. Oh, because I guess, so technically he's 3.4 meters above the ground, like this, right? But he only plunges that high because the flower is up there. Details. Okay. So it says, what is the hummingbird's total displacement? So from point A to point B, what is this? And we just go ahead. Oh, let me actually, before I begin, this is where he starts. That's the origin. North, east, southwest. And again, this is going to be somewhere in this quadrant right there. So we have to think about the whole thing. Okay. Okay, so C equals the square root of, I'm going to go ahead and do A squared 1.2 squared meters plus B squared 1.4 meters squared. Can you see those numbers okay, Steph?
Zooming.
And I get 1.84 meters. Okay, the question is, at what degree? So let's go ahead and find this angle right here. So the angle is the inverse tangent of my opposite, which is 1.4. Oh, I don't need to put the meters in there. Divided by 1.2. 1.4, and I'm going to call it 50. Okay, it's 49.4. We'll call it 50. Okay, so this is 50 degrees, and this is 90 degrees. 90 plus 50 is, no shame in the game, use that calculator, 140 degrees. Now again, if you wanted to say it's 50 degrees below the horizontal, that is also fine. Okay, that's everything. I hope this helped.